Okay, so our last lecture is a pretty straightforward one, and it's on this topic of what we call Pylint. Um, Pylint becomes relevant in your week 3 um, uh, week 3 labs, and it becomes relevant in iteration 2. Nothing we talk about today has to be applied to iteration 1 for Pylint, but it will be applied in iteration 2 and onwards, and you'll start to see it being required in your labs as well. So what the hell is Pylint? Pylint's a way to maintain good style. Sorry, just funny chat. So programs are written for people to read. Code is for humans. We don't write code for machines. We write code for humans. And that makes sense, right? Because our code's compiled. Like, computers don't give a damn what we write. Like, we write code for other humans to read. So it's really important that our code is clean, clear, consistent, and everything like that. You're aware of this because ever since you started programming, you've been exposed to style guides where it says things about indents and how to declare functions and camel cases and everything like that. The problem is that maintaining style manually is both challenging, you're going to get it wrong, and also it's just not how it works in the real world. So in the real world, what actually happens is that people use automated tools they basically have automated tools that like does the styling for them to an extent. And we're going to talk about that in the context of Python. So these modern tools that are used in Python, one of them is called Pylint. Now what Pylint is it's called a static analysis tool for Python code. When we say static analysis, I think this is a really important term to talk about. What does static mean? Static refers to code that's not running. Basically, it refers to your text files before you actually run them. When you write PyTests, you're kind of doing dynamic checks. And what I mean by that is you're actually having to run the Python to check that it's all working. Static testing, though, is when you actually just check the source code before everything runs. Right. So if you haven't even used, you could run a static analysis tool before your code ever even runs. There are limitations to static analysis, right? There are limitations to what programs can check with code that isn't running. But generally, it can detect some errors. It can find potential errors, and it can most importantly, ensure that your code follows a style guide. And Pylint is a program that lets us do this. It lets us statically analyze our code. And I'll show you how it works. So if I just start a new file, and I'll just call this file like badcode.py, and I just write some simple bad code like name equals Hayden. I make it kind of ugly. I don't even know how to write bad code. Print name plus string 5. I don't know. Def hello, which is just going to print hi. And then we'll just call hello like this. Really random Python code. Yes. So if I run this badcode.py, it works, right? So it functions, but let's actually run a static analysis tool on it, which is Pylint. So if I do Pylint and then I run bad code, it's kind of like PyTest, right? Like Python 3 executes Python code. PyTest looks through Python code to find test files and executes it. Pylint does not execute the code, but it does read through the code and find issues with it. When I run Pylint on code, what it does is it looks through it and it gives me a report, and it basically says, here are some issues you have. And then it gives me a score at the bottom, which I got 0 out of 10. High 5. Good job. And you can see there's 5 things that they found wrong here. The first one is on line 5, it says bad indentation. It found 1 space when it expected 4. And that's because Pylint is expecting that I use 4 space indentation, and it's treating this tab like a single space, right? So if I fix that up, right, and then I run this again, you know, this isn't running my Python code, it's just looking at the source code. When I run this one again, it will statically analyze my code, and it will probably get rid of that line 5 error here. So it should just give me 4 errors next. Okay, I've got 4 errors. Now it says final new line missing. So in most I don't fully understand why, I won't lie. Most kind of style guides will expect you to always have a trailing empty new line in your program. So at the end of every program you write, you have an empty new line. I'm sure there's a very logical reason for it. I've just never bothered to Google it. Now I have 3 errors. It also says here on line 1, the constant name doesn't conform to uppercase naming style. So when you define constants in the global scope, it expects them to be uppercase. Actually, I think it expects all constants to be uppercase. And now you can see that I have 2 last errors, which is that I'm missing a module docstring and a function docstring. So a module docstring is what they refer to as like the docstring at the top of every file. Hello? I don't know if this will work. Yep. So you see that what Pylint's actually checking is that I have the ~3 block comments. It's not actually checking what's inside of it. So this would be correctly Pylinted code that is not Pythonic because the comment is trash. Right? And then we could also add a trash comment, which we shouldn't do, to inside of our function. And then, voila, 10 out of 10. It all works. Now what you notice is that it's trying to improve the quality of our code by making it work to a particular standard. Miguel says, can you run Pylint for an entire directory at once? You can. So now that we understand Pylint, which is really quite straightforward, there's a bunch of rules that you have to follow. Let's talk about a couple of important, I guess, other factors involved. First one is, why is it called lint? Because a linter is a thing that... what a stock image. A lint is one of these things, you see them, they're like the first thing you can buy when you walk into an IKEA downstairs usually. And they pretty much get rid of dust and other crap, right? They just like polish off your clothes by getting rid of the crap. And that's kind of that's why it's called Pylint, because it's a Python-based linter. If you just run Pylint in a folder, it will give you basically the full help message where it shows you all the different commands you can run. And usually there'll be some hints here about like what you can do with it. If I do Pylint star, it'll Pylint all of my files probably. So this is it trying to Pylint all of my files, which is a lot, right? Yes, it's for real. It is the lint roller. So you can run Pylint on all your files pretty easily by doing that. You can also like do things like */.py, which will go get like, oopsie, oh, it's not grum. That's not good. Have I done that wrong? I've confused it. That's okay. You can just do *.py for now. So you can run it on all your files. One of the important things to know though is that Pylint checks not based off some universal unchangeable set of rules, but actually it does it based off kind of like a rule set, like a document, like a configuration file. And if I actually run this command here, pylint -- generate RC file, it actually outputs for me a Pylint's default configuration. And if I output that to a file, which is pylint RC, I actually will now have another file in my repo here in this week 3 folder. Hurry up, get to it. Piece of crap. All right, what are some questions that have been asked? Will we get penalized if we don't get a certain score on Pylint for our projects? Yeah, from iteration 2 and 3, you'll get pretty heavily penalized if you don't have a 100% Pylint score. But Pylint's really not that hard to get right. There's a problem, you fix it. There's a problem, you fix it. It just takes time. You know. Okay, so in my folder now, I have this .pylintrc file. Now the way Pylint works is when I run Pylint on something, right, it first checks, do they have a .pylintrc file in this folder that I'm being run in? If the answer is yes and that file exists, Python will use the RC file as the configuration. If it doesn't exist, Pylint will use its default configuration. So when I run my bad code here, it says it's all fine. But let's actually open up the Pylintrc. And let's actually find like space or something. I'm sure there's a point where it says like =4 for spaces. Space? Indent after parentheses. Maybe not. Let's find something else. Here you go. Max line length is 100. Now that makes sense. If I have like a really, really long line that's over 100 characters and I run Pylint, it'll complain. It says line too long. If I make that line smaller, say only 53 characters, it works now. Done. But if I update my Pylintrc to say that the maximum line length should be 50, when I run Pylint, it will look up the Pylintrc in my folder and it will say the line is too long. It's 52 characters when it should be 50. In your labs, we give you a Pylintrc that has a couple of things turned off. It's a little bit nicer, I think, than Pylint's default one. When we push your iteration 2 stuff to your repo Monday next week, we will give you a Pylintrc. So you never need to worry about configuring a Pylintrc, but you do need to understand how it works. So that's about it. Are there any other questions about Pylint? It's actually a pretty straightforward lecture. If we finish early, maybe we can do Teamwork Tuesday now. Save myself some time tomorrow. Is there a way to set up a GitLab pipeline that runs Pylint on all merge requests? Yes. Any labs or project where we expect you to do that, we add that to the pipeline. I think next week or the week after we talk about how the GitLab pipelines work, but the short answer is yes, that'll all be handled for you. There's the poll for the Pylint lecture. Okay.